In a revealing announcement that could change our position in the cosmos, NASA has reported the detection of the first extraterrestrial signals coming from the direction of Proxima B, the closest known exoplanet to Earth, located just over 4 light years away in the habitable zone of its star, Proxima Centauri. This discovery has generated a wave of excitement and curiosity worldwide. Could this be the moment when humanity discovers that it is not alone in the universe? The road to this momentous discovery began with meticulous observation by NASA's powerful telescope, which had been monitoring distant stars and planets for signs of life. Proxima B has always been a leading candidate in the search for extraterrestrial intelligence because of its Earth-like characteristics and its proximity to our own solar system. The signal detected is distinctive and unlike anything astronomers have ever observed before, marking a possible turning point in human history. The implications of such discovery are profound. First, it confirms the long-standing scientific hypothesis that life could exist on other planets under Earth-like conditions. Second, and perhaps more intriguing, it raises the question of the nature of the civilizations that might reside there. Would they be mere microorganisms or advanced beings possibly capable of interstellar communication and travel? This signal from Proxima B is not simply a random noise or a natural cosmic phenomenon. It carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams, are now tasked with deciphering this message, trying to understand its content and the intentions behind it. The global scientific community is abuzz with theories and speculations about the possible content of this message: a guide, a greeting, a warning, or something completely unimaginable. News of this discovery has gone beyond the confines of the scientific community, sparkling debates on social media, in government rooms, and on dinner tables around the world. People are looking up at the stars with renewed wonder, pondering beings who might be doing the same thing on a distant world. How similar or different might their world be to ours? What would their society be like in terms of technology and culture? These possibilities seem as vast as the universe itself. In addition, this detection opens up a number of ethical and existential questions. How should humanity respond if the signals really come from intelligent beings trying to communicate? What protocol should we establish for interstellar diplomacy? And most importantly, how would such a discovery change our understanding of religion, life, and our very identity as human beings? While excitement is growing, there is also palpable wariness. Cutting-edge scientists at NASA and other space agencies are working diligently to validate these findings, ensuring that the signal is not a false positive or a misinterpretation. We are on the brink of what could be the most significant discovery in human history, so the next steps must be taken with precision and responsibility. The world waits expectantly for more detailed analysis. The detection of alien signals from Proxima B not only propels our scientific efforts into a new era, but also unites us with a collective curiosity and hope. We could finally be on the brink of answering one of the oldest and most profound questions: are we alone in the universe? In April 2019, a radio signal was detected coming from outer space, specifically from the Proxima Centauri region, 4.37 light-years away from us. Although it may seem a considerable distance, it is the closest star to the Sun, being 3 times farther away than the third brightest stars in our sky. The signal comes from a triple star system composed of the binary pairs of Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the 2 stellar companions, are relatively close to each other and are quite similar to the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright, with an orange hue. Alpha Centauri A is slightly larger than our Sun. Alpha Centauri B is also smaller, so our Sun fits exactly between them in size. But where did the signal between these 2 stars come from? The groundbreaking Breakthrough Listen project, dedicated to searching for extraterrestrial communication in the universe, has named this signal Breakthrough Listen Candidate 1, BLC-1. The project, which has approximately $100 million in funding, has used thousands of hours of observation with state-of-the-art telescopes around the world. The signal was detected by the Park C-Cyrus radio telescope in New South Wales, Australia. This telescope was observing the region of Proxima Centauri, the closest star to our Sun. The signal almost went unnoticed among the vast volumes of data collected over thousands of hours, but the scientists managed to identify it like a needle in a haystack. For the signal to be considered relevant, it must have two definite characteristics. First, it must be limited to a small frequency range, since such radio signals are not created by natural mechanisms in space. Second, the frequency must fluctuate according to the relative motion of the exoplanet with respect to Earth. The scientists had to analyze nearly 4 million individual signals captured by the telescope in Australia. After an exhaustive process of filtering and eliminating unnecessary signals, they found 5,000 distinct signals, among which one stood out: a signal that could not be explained after cross-checking with contemporary radio transmitters on Earth. This unique signal, with a narrow-band technological signature, only appeared when the telescope was pointed towards Proxima Centauri and was observed over a 30-hour period. After in-depth analysis, it was determined to be Proxima B, an exoplanet discovered by astronomers in 2016 using the radio velocity method, which detects variations in a star's position caused by the gravitational pull of orbiting planets. The star will describe a small circle. Extremely sensitive spectrographs are used by researchers to follow the light from a star. The spectrum of starlight shifts slightly towards blue as it approaches a planet and towards red as it moves away from it. When these shifts occur repeatedly and regular over days, months, or years, it is accepted that the variation in light is caused by the gravitational pull of an orbiting planet. On closer examination, Proxima B turns out to be very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of Earth, indicating that it is a rocky world with an equivalent density. However, there are significant differences. The first is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star, at only 0.05 astronomical units, while Mercury is at a distance of 0.39 astronomical units from the Sun. This proximity would make Proxima B an extremely hot planet, but because Proxima Centauri is a dim red dwarf, the planet receives only 60% of the energy that the Earth received from the Sun, placing it in the habitable zone where life could exist. There are countless unknown planets scattered throughout our universe. So far, we have discovered an impressive 4,935 exoplanets and have recently added 65 new planets to our tally, bringing the total to 5,000 planets. This latest group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a milestone in planetary exploration. The James Webb Space Telescope, the JWST, is the most advanced telescope ever built, being 100 times more powerful than its predecessor. With its help, we will be able to unlock the secrets of this vast spans of the universe. In the past, we have discovered a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as extremely hot planets and habitable ones. Among these discoveries, a few planets stand out in particular. Kepler 1649c is one of those planets whose characteristics are very similar to Earth. In fact, it is the most habitable planet we have found so far and could harbor life. So far, we have identified 55 Earth-like planets, but we have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially thanks to the James Webb Telescope, who knows what more we will be able to achieve in the future. Wouldn't it be amazing to find a planet capable of supporting life? One of the main goals of the James Webb Space Telescope, during its first year of science missions is to find and study extraterrestrial worlds beyond our own solar system, focusing on how they form and the possibility that they can contain water and biological life. Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as link our own solar system to their origins. Webb's infrared capabilities are ideal for revealing how stars and planets form for three peculiar reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are 20 times denser than visible light, which is especially important when observing newborn stars that are hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation, when gas and dust are still contracting to give birth to young stars. But there is much more to the natal clouds of stars than that. Both young stars and giant planets begin as huge swollen structures that gradually contract over time. As newborn stars get hotter as they age, giant planets cool, but both emit more light in the infrared spectrum than at visible wavelengths, which means that the Webb Telescope will be excellent for finding new stars and planets and helping to understand the physics of their formation. Webb's MIRI instrument will also search for hot molecular gas near numerous young stars, which could indicate the formation of potentially habitable rocky planets. Not surprisingly, much of the James Webb Space Telescope early science work will focus on determining how planetary systems build molecules that may be crucial to the emergence of life. The James Webb Space Telescope has found evidence of human activity far from Earth, bringing us closer to answering the age-old question of our solitude in the universe. The research for extraterrestrial life has been a constant throughout human civilizations, generating thousands of literary works and theories on the subject. Our fascination with our place in the universe and the possibility of not being alone seems to be ingrained in us, driving us to seek companionship, even if it's of extraterrestrial origin. We're getting closer and closer to finding answers to questions we really want. But are these answers really what we seek? Or is there something deeper at play? In 2021, the James Webb Space Telescope posed a hypothetical question about the future capabilities of our technology. Could our telescope detect artificial light on another planet, such as Proxima B? This exoplanet, the closest to Earth, lies in the habitable zone of our nearest neighboring star, Proxima Centauri, about 4.25 light-years away. Proxima B was believed to be locked in synchronous rotation, similar to the Moon with Earth, with one side always facing its star. A possibility was raised that a technological civilization on Proxima B could transfer the heat and electricity from the day side to the night side using probalictic cells that generated electricity from sunlight. Subsequently, a paper with Manas V. Lingam as one of the researchers showed that significant coverage of the day side with solar panels could be detected by future telescopes. Given that the James Webb Space Telescope represents a more advanced technological advance, now in 2024, there is a possibility that will allow us to expand our research for possible artificial lights on habitable exoplanets such as Proxima B. Thanks to its increased sensitivity and range of capability, the JWST may have discovered the light we've been looking for, which could propel humanity towards another great leap in its evolution. But before we dive into the implication of the discovery, it is crucial to understand how this feat was possible. The James Webb Space Telescope mission explores the mysteries of Proxima Centauri B. Throughout history, humankind has sought answers to understand the fundamental questions about the universe, our existence, and destiny. These common but extremely difficult questions have been driven humanity's curiosity for as long as we have been conscious. In the current era of exponential technological advances, the question arises as to whether we are any closer to finding answers. While a philosopher might argue that we're still at an early age in our understanding of the universe and ourselves, and astronomers would be excited to share the latest discovery about the cosmos, using the technological tools at his or her disposal. Although these advances often go unnoticed by the general public, they truly represent milestones in human evolution. Now, with the world literally at our fingertips, it is time to move forward and explore the universe in ways never before imagined. One of the ways of exploration is through technology, such as the James Webb Space Telescope. This instrument, heir to the legacy of human space exploration, is destined to answer fundamental questions about our place in the cosmos. It has already begun to shed light on the possibility of life beyond our solar system, as evidenced by the recent discovery of possible lives on a planet light years away. Proxima B, also known as Proxima Centauri B, is a super-extraterrestrial exoplanet orbiting an M-type star. These planets, more massive than Earth but lighter than ice giants like Neptune or Uranus, are a unique class in the universe. Although much remains to be discovered and understood about Proxima B, this breakthrough represents a significant step forward in our quest to better understand our place in the cosmos. The first possible evidence of an exoplanet dates back to 1917, although at that time it barely captured the attention and recognition of the scientific community. However, it was in 1992 that the first detection of an exoplanet was confirmed, astounding scientists. Since then, many other exoplanets have been confirmed, with another notable example in 2003. By April 1st, 2024, a total of 5,653 exoplanets have been confirmed in 4,161 planetary systems, of which 196 have been more than one planet. These marvelous discoveries are mostly associated with M-type stars, also known as red dwarfs. Red dwarfs are the smallest stars on the main sequence that are considerably more common in the Milky Way than other stars. However, due to their low luminosity, observing them is not as easy as with other stars. Red dwarfs have different classifications and names according to their temperature and sizes, often designated as M dwarfs. These stars, with a temperature of about 3,900 Kelvin, have specific characteristics that distinguishes them. As Proxima B, its mass is estimated to be about 1.07 times that of Earth. Remarkably, it completes an orbit around its star in only 11.2 days, compared to our Earth year of 365.25 days. This gives us an estimate of the size of the star orbiting Proxima B. The star's luminosity is surprisingly low across the electromagnetic spectrum, at only 0.16% of the sun's luminosity. Moreover, in the visible spectrum, its luminosity appears even dimmer, emitting only about 0.056% of the sun's luminosity. More than 85% of the energy it emits is in the form of infrared radiation, and it orbits at a distance of about 0.4856 astronomical units from its star. The discovery of Proxima B was announced in 2016, which raises the question of why this particular exoplanet has generated so much interest. One of the reasons is that Proxima B is the closest known star to our Sun, albeit at a distance of 4.2 light years, which, while larger to us, is relatively short on a cosmic scale. It is part of the triple star system known as Alpha Centauri, and despite its low luminosity, remains an object of great interest to astronomers. The Proxima Centauri system stands out as one of the constellations visible in the night sky, ranking behind only two others, known as Sirius and Procyon. However, the most intriguing thing about Proxima Centauri B is its potentially habitable position within the habitable zone of its star. Possibilities they suggest are limitless, which has led astronomers to embark on an expedition to explore the depths of this stellar potential. This is where the James Webb Space Telescope comes into play. The four main goals of the JWST include searching for light from the first stars and galaxies that formed after the Big Bang, studying the formation and evolution of galaxies, understanding the formation of stars and planets, and investigating planetary systems and the origins of life. As JWS continues its exploration of exoplanets such as Proxima B, we move ever closer to achieving these goals. The search for extraterrestrial life is a particular area of interest in space exploration. The Search for Extraterrestrial Intelligence (SETI) project stems from the curious nature of humanity, exploring all that moves and all that does not move. SETI imagines a kind of cosmic treasure hunt, where instead of gold, we are in search of electromagnetic signals that could be whispers of civilizations beyond our wildest imaginations. The universe has always jealously guarded its secrets, especially about the existence of extraterrestrials. As humanity, we have done and continue to do everything we can to unravel these mysteries. Our thirst for knowledge has revealed much, and with the James Webb Space Telescope in our arsenal, the possibilities are endless. In a recent breakthrough, the James Webb Space Telescope sent back new high-definition images of Proxima B, a world believed to harbor extraterrestrial life outside our solar system. These images showed something surprising and extraordinary, fueling our search for habitable exoplanets and the potential for extraterrestrial life. The universe formed about 13.8 billion years ago and has evolved into what we know today. Planets and moons emerged, establishing dynamic and ever-changing relationships. Since humans began observing the night sky, we have sought to understand this cosmic relationship, using our ingenuity to develop advanced tools to aid us in our search. The James Webb Space Telescope, JWST, the most advanced to date, acts as our eyes to investigate celestial objects and events. It has allowed us to explore the depths of space and improve our understanding of the universe. Its infrared capabilities revealed previously unknown cosmic features, investigating the origins of galaxies, stars, and planets, and searching for signs of extraterrestrial life beyond our solar system. Equipped with sophisticated filters, the JWST has allowed scientists to map the cosmos, detecting various features and mysteries that previously telescopes could not. Although we have not yet realized its full potential, the JWST discoveries have been astonishing and promise to revolutionize our understanding of the universe. For example, it has been discovered that the universe has a greater mass than previously thought. With each discovery, the James Webb Space Telescope, the JWST, unravels the mysteries of the cosmos, revealing its secrets galaxy by galaxy. However, the story does not end there. Recently, the James Webb Space Telescope has achieved a new feat by sending the first clear image of Proxima B. This discovery dates back to 2013, when scientists detected a slight gravitational pull between planets and its parent star, called Proxima B. This celestial body is a planet that orbits Proxima Centauri, the closest star to our Sun. This discovery was exciting news for the scientific community, as it was like finding a new neighbor in space. Proxima Centauri is part of a system made up of 3 stars and is only 4 light years away from Earth, making it the closest star to our solar system. Although Proxima B appears to be 25 light years away, it is actually one of our closest planetary neighbors beyond our solar system. Imagining the possibility of traveling to a newly discovered world so close to our own is fascinating. This exoplanet is slightly larger than Earth, with a mass of about 30% greater than our own home planet. However, what really captures the imagination is its extreme fast orbit, completing one cycle in just 11.2 Earth days. This rapid evolution of Proxima B is due to its close proximity to its parent star, orbiting about just 7.3 million kilometers, a relatively short distance compared to the distance between the Earth and the Sun. Scientists expected Proxima B to be scorching hot. Hot because its star is small and emits much less heat than our Sun. Proxima B's surface is not as hot. Instead of a bright sun like ours, Proxima Centauri would appear as a faint crimson sphere with a diameter 3 times that of the Sun. Additionally, if Proxima B is in its star habitable zone, known as the residual zone of Oro, where temperatures are neither too hot nor too cold. The data suggests that there could be water on the planet. The possible presence of water on Proxima B has sparked great interest in the scientific community, as this could mean that the planet could support life. Scientists are eager to learn more about this mysterious planet. However, some significant concerns temper our interstellar aspirations. One is that Proxima B could be trapped in a state known as tidal coupling, where one side always faces the star while the other remains in perpetual darkness. This fact is not favorable for the development of life. Additionally, there is a big problem with water turning into steam. If there is water near the star, it will heat up quickly and will turn into clouds of vapor. On the other hand, if a planet moves too far from its star, it will become extremely cold, making the existence of liquid water impossible. But that's not all. Although Proxima Centauri is much smaller than our Sun, it has a stormy core that creates strong magnetic fields. These fields release a lot of radiation and bursts of cosmic particles, posing formidable challenges for planets located within the habitable zone of stars, such as Proxima B. Therefore, the possibility of life is minimal. Until recently, scientists didn't know much about the magnetic field around Proxima Centauri. But with the new technology, they have learned a lot. A recent study found that Proxima B receives a lot of radiation from the star's solar wind, 1,000 times more than Earth. This enormous amount of radiation makes it difficult for any form of life to survive. An example of how wild this environment can be was seen when Proxima Centauri released a massive burst of energy called the mega flare, 100 times larger than any solar flare of our own Sun has ever seen. This giant explosion in space further reduces the possibility that Proxima could host life, despite the exciting idea that it could. The conditions around Proxima B are probably too harsh for any life form we know. Interest in this planet peaked in late 2020 when scientists detected a strange signal coming from the Alpha Centauri region, where Proxima Centauri is located. The intriguing thing about this signal is that it has a frequency of 982.551 MHz. New discoveries from the James Webb Space Telescope, the JWST, have revealed something fascinating. The data suggests that Proxima B could have water vapor in its atmosphere. This finding is very important because water is crucial for the existence of life. Determining how much water there is in Proxima B is like solving a big space puzzle. Scientists are using advanced tools such as spectroscopy and atmospheric modeling to learn more about Proxima B's atmospheric composition. Spectroscopy is a specialized tool that helps scientists identify the gases present around Proxima B. This technique reveals important atmospheric compounds and their composition, such as oxygen, methane, and carbon dioxide, which are essential ingredients for life. Another useful tool is atmospheric modeling, ATM, which creates a computer model of what Proxima B's atmosphere could be. Scientists can adjust different scenarios and variables, similar to how a dinosaur model is made, to imagine what it was like when it was alive. This technique helps us unravel the mysterious veil covering Proxima B's atmosphere and determine whether it could be a suitable place for life. As we move forward, there are still many unknowns, so it is essential to continue exploring and learning about this planet. Despite the harsh conditions surrounding the star Proxima Centauri, scientists are hopeful of finding inspiration on Earth, where there are tiny extremophile organisms that can survive in places previously considered impossible. These organisms are found in hydrothermal vents in the deep ocean, in highly acidic lakes formed by volcanoes, and even in the frigid cold of Antarctica. Their ability to thrive in unexpected environments demonstrates incredible adaptation and resilience. Given the astonishing resilience of life on Earth, the idea of finding life on a planet like Proxima B seems increasingly plausible. Extremophiles have expanded our understanding of where life can exist, challenging what we thought possible by surviving in places that seemed uninhabitable. This gives us hope that similar life forms may exist on distant planets like Proxima B, which are being actively studied. Let me know your opinion in the comments box. Like if you liked the video and subscribe so you don't miss out on more content like this. Thank you so much for watching, and I'll see you in the next video.